is question 55 of Civil Engineering paper of GATE 2019 forenoon session. A square footing of 4 meter side is placed at 1 meter depth in a sand deposit. The dry unit weight of sand is 15 kilonewton per meter cube. This footing has an ultimate bearing capacity of 600 kilopascal. Consider the depth factor dq is equal to d gamma is equal to 1 and the bearing capacity factor n gamma is equal to 18.75. This footing is placed at a depth of 2 meter in the soil deposit. For a factor of safety of 3 as per Terzaghi theory, the safe bearing capacity of this footing would be. So this problem is from the topic of Terzaghi bearing capacity theory. You may watch lecture 9 Shallow Foundation and Bearing Capacity, Geotechnical Engineering 2 Foundation Engineering by Professor Dilip Kumar Vaid, IIT Kharagpur for detailed knowledge and derivation of the Terzaghi bearing capacity theory. So in this question, a square footing of 4 meter side is given and the depth of footing is 8 meter and the soil deposit is sand. The unit weight of the sand is also given as 15 kilonewton per meter cube, and for this condition the footing has an ultimate bearing capacity of 600 kilopascal and the depth factor dq and d gamma is 1 and the bearing capacity factor n gamma is also given 18.75. Now in the second case it is saying that the same footing, that is a square footing of 4 meter side, is placed at 2 meter depth in the same soil deposit. Now it is asking for a factor of safety 3 what will be the safe bearing capacity. So let's recall the formula first for the safe bearing capacity. So in the Terzaghi ultimate bearing capacity, the QU, that is ultimate bearing capacity, there are three formula for a strip footing, for a square footing and for circular footing. So for a square footing, since in this question a footing is having a square shape, so we will use the formula QU is equal to 1.3 CNC plus QNQ plus 0.4 gamma BN gamma for a square footing. Now net ultimate bearing capacity formula QNU is equal to QU minus gamma DF, and next net safe bearing capacity formula QNS is equal to QNU divided by factor of safety. Next the formula safe bearing capacity QS is equal to QNS plus gamma into DF. So here we should calculate the safe bearing capacity, that is QS. So for calculating QS we must know the value of QNS. So here we can find the QNS with the help of this equation, and in this equation we should know the QNU, that is net ultimate bearing capacity, which is calculated by this formula QU minus gamma DF. It means we must know the value of QU, that is ultimate bearing capacity. So in this question the value of C will be 0 because the soil deposit is sand. So we can write QU, first we should find QU. QU is equal to 1.3 CNC plus QNQ plus 0.4 gamma BN gamma. Now since this C is 0, so this term will be 0, and this Q is the overburden pressure, can be calculated by gamma into DF. So unit weight and depth of foundation is known, but this NQ is not known for the second condition. So we can find this NQ with the help of data given in the first paragraph, okay, in the first case. So apply all this data in this equation. So QU is given for the first case, when for the first case when the depth of foundation is given as 1 meter. 1 meter. You can see in the first paragraph, the depth of foundation is 1 meter is given. Okay. So ultimate bearing capacity is also given at 600 kilopascal. So applying this, so we can say this ultimate bearing capacity is given as 600 kilopascal. 600 kilopascal is equal to Q n cube. So Q is gamma into df. So gamma is 15 and depth of foundation is 1. So we can write gamma into df into nq plus 0.4 b, this gamma is 15.4 gamma b, width of the footing. So width of the footing is 4 meter into n gamma. N gamma is also given as 18.75. So we can calculate it. 600 is equal to 15 nq plus, just after calculation we will get this as 450. So we can find this nq as 10. Now with the help of this nq and all the data given, we can find the ultimate bearing capacity of the footing for second case when the depth of footing is 2 meter. So we can say for the second case, when depth of footing is 2 meter, we can find Qu with this formula. So CNC, the first term is 0. Why? The soil deposit is sand. C is 0, cohesion is 0. Now QNQ means we can write QNQ plus 0.4 B gamma n gamma. Now Qu is equal to, Q means overburden pressure, gamma into df. So gamma, that is unit weight of soil, is given as 15. Depth of foundation is 2. NQ we have just calculated as 10 plus 0.4. B is the width of foundation, which is given as 4 meter. Gamma is the unit weight of soil, which is given as 15. And N gamma is, in this question, N gamma is 18.75. 18.75. So we get Qu is equal to 750. So we get Qu 750 kilopascal. Now after calculating Qu, we can find the net ultimate bearing capacity Qnu. Qnu is equal to Qu minus gamma df. So Qu we have calculated 750 minus gamma is the unit weight, that is 15, and depth of footing is 2 meter. So it comes as 750 minus 30, that is 720 kilopascal. Now we can find the net safe bearing capacity QNS. QNS is equal to QNU by F. QNU by factor of safety. So it will be 720 divided by factor of safety. We should take 3 as it is given in the question. So 720 by 3. So it will be 240 kilopascal. Now we can calculate the safe bearing capacity QS. QS is equal to QNS plus gamma into df. So QNS we have calculated 240 kilopascal plus gamma, that is unit weight of soil 15, df is the depth of foundation. So we got 240 plus 30, that is 270 kilopascal is the safe bearing capacity for the second condition, that is for when the footing is placed at 2 meter. So we can say the safe bearing capacity of this footing would be 270. So 270 is the correct answer for this question. Thank you.